Namaste everyone and welcome back to our channel. Today, we are diving into a super important topic for any developer working with databases, SQL Joins, and how we use them effectively in Java. Understanding joins is absolutely crucial for retrieving meaningful, combined data from multiple tables. It is like putting together pieces of a puzzle to get the full picture. In this tutorial, we will explore different types of joins, their SQL syntax, and most importantly, how to execute these queries using Java Database Connectivity, or JDBC, in your Java applications. By the end of this session, you will be confident in fetching complex data sets and building more robust database interactions. So, let us get started on this exciting journey to master SQL joins with Java examples. Alright, let us begin with the most common type, the inner join. Imagine you have two tables, for example, an employees table with employee details and a departments table with department names. An inner join helps you combine rows from these two tables only when there is a matching value in a common column in both tables. Think of it as finding the intersection between two sets of data. If an employee does not have a matching department ID, or if a department does not have any employees, those rows will simply not appear in the result. It is all about finding the exact matches. On our whiteboard, you will see the SQL syntax for an inner join, followed by a Java snippet demonstrating how to use JDBC to execute this query and print the combined results. Pay close attention to how we establish the connection, create a statement, execute the query, and then iterate through the result set. Next up, we have the left join, also sometimes called left outer join. This type of join is incredibly useful when you want to retrieve all records from the left table and only the matching records from the right table. If there is no match for a row in the left table, the columns from the right table will simply show as null in the result. Consider our employees and departments example again. A left join would list every single employee, even those who might not have an assigned department, alongside their department details if available. This ensures that no data from your primary table, the left one, is lost. You can see the SQL syntax for a left join on the whiteboard. Following that, we have a Java example using JDBC, very similar to our inner join, but now executing a left join query. Notice how the Java code structure remains consistent, making it easier to adapt for different join types. Moving on, we have the right join, or right outer join, which is essentially the mirror image of a left join. With a right join, you get all records from the right table, and only the matching records from the left table. If no match is found for a row in the right table, the left table's columns will be null. So, using our example, a right join would list every department, even those with no employees, alongside any employees belonging to them. It is crucial to understand which table serves as your primary focus. We also have the full outer join, which returns all records when there is a match in either the left or the right table, showing null for non-matching sides. While less common in practice due to potential large result sets, it is good to know it exists. The whiteboard shows the SQL syntax for right join and a quick mention of full join, followed by a Java example demonstrating how to execute a right join query using JDBC. Again, the Java code structure for executing the query remains quite similar. Now, let us talk about some common mistakes and important tips when working with SQL joins in Java. A frequent error is forgetting the ON clause in your SQL query, which tells the database how to link your tables. This will often lead to a Cartesian product, returning far too many rows and potentially crashing your application. Always specify the join condition clearly. Another important tip is to use table aliases to make your SQL queries more readable, especially when dealing with many tables or long table names. For example, select e.name from employees, e.join departments, d on e.department underscore id is equal to d.department underscore id is much cleaner. And in Java, always ensure you close your database resources, your connection statement and result set to prevent resource leaks. Using Java's private resources statement is the best practice for automatic resource management, making your code robust and efficient. These practices will save you a lot of headaches. And that brings us to the end of our tutorial on SQL joins with Java. We have covered the essential types of joins, inner join, left join, and right join, understanding how each one combines data from multiple tables. We have also seen practical Java database connectivity, or JDBC, examples for executing these queries and handling the results in your Java applications. Remember, mastering joins is fundamental for any serious database interaction, allowing you to fetch complex, meaningful data. Keep practicing these concepts with your own database schemas and Java code. The more you practice, the more intuitive it will become. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming tutorials. Happy coding, and I will see you in the next video. Dhanyavad.